Day 41. Welcome to Breakfast in Biology.
Happy Formal Wednesday.
Yes, I got dressed up for you. It's just getting sillier and sillier. Look who's in the house today. Emma Bryant, the Lurker, Maya, Eli, Diana, Emily, Abby, Finley,
Carissa, Annie, Gladys, Abby, Dom, Radika, Darius. Who
Dom
else is
said,
there?
"What's up?" Darius said that shit.
Zuli, William, Supreme Ginger, Alex, Cameron. Haven't seen him for a few days. Cameron, are you finally feeling better? Jake,
I
Alex,
didn't see William for a few days either.
Lexi. Yeah.
Oh, that's bad.
What's bad?
Michael Jackson's here again.
Dude,
Actually, I'm bad.
Oh. Boy.
Here. So, ladies and gentlemen, hey, thanks to everybody that did the Punnett Squares and attempted those already. We appreciate that. Thanks for everybody that's keeping up on their work. We appreciate that. Mrs. Smith and I feel like there might be like when they were talking about flattening the curve, not the curve on how many people were turning work in. We want that curve to keep going up exponentially. I feel like there's a few people that still need to make stuff up. What do you think, Mrs. Smith? Okay. So let's get right into it. We assigned problems 3 and 4 for you yesterday. One of the things that we've been trying really hard to do, because we're not together, we can't have as many individual conversations with you. Not that we don't want to. We're happy to if you just reach out and let us know. Is to go over the things that we're assigning. So we thought today we would go over problem 3 and 4. The ones that were turned in last night, for the most part, they looked really good. I did see some mistakes here and there. So we would go over problems 3 and 4. And then we were like, should we try something new, start something new, maybe assign another problem or two? And we thought, wow, we assigned another problem or two. That's like another Google Doc. You have to make another one. We have to check. So what we're going to do is just go over a few. So today we're going to go over the ones that were assigned, a couple extra, and then tomorrow probably we're going to talk about some unique circumstances with this stuff. And probably start wrapping up genetics. So that's the plan. We had 15 days on Monday, including today we have 13 days of this left. And I know that you're worried about this because you're going to miss us. We're worried about it because we're going to miss you. All right.
True.
Let me share my screen. Monohybrid problems. All right. We assign 3 and 4. So let's start with 3. I'll start with 3 because 3 is easier than 4, and I want Mrs. Smith to do the hard one. Or something like that. Here we go. In garden peas, round peas are dominant to wrinkled peas. And I think the first thing when you read these questions you got to look for is that piece of information. What is the dominant? So what is the trait? Round peas are dominant to wrinkled peas. If you cross a homozygous dominant, that will be one of our individuals. We'll make them mama bear. And you cross a homozygous recessive. So we have a homozygous dominant, homozygous recessive. We're going to make that papa bear. What would be the genotype and phenotype of the offspring? Great. Let's do it. What's the trait? We highlighted it. So it is round peas are dominant. So shape of the pea. Remember peas on Earth? What's dominant? Round. What's recessive? I always do these first. Wrinkled. Get them in there. And then I think about the letter. I like the letter R. I don't have a problem with the letter R. A big R looks different than a lowercase r. I'm good with that. It's all good. R's are good. I like R's. They roll right off the tongue. They're fine. Use R's. So what is the cross? The cross is a homozygous dominant times a homozygous recessive. It really doesn't matter which one's male and female at this point, unless they say. It doesn't matter. So homozygous dominant. I'm going to come back up here and I'm going to, oh, can we do this? What if I change that? Damn, look at that. I'm changing that just to really point out that homo means same. When you see the word homo, we've used it several times this year. It means same. So a homozygous dominant, a same dominant means I need 2 big R's. So my cross is going to be big R for that guy. The next one, look, I can do it again because I'm special. Bam. Homo again means same. Homozygous recessive. My recessive is a little r. We wrote it right there. Little r, little r. All right. You with me so far? Good. So we just got to fill out this Punnett square. We got to take one individual and put it at the top. Be careful because one of the things I've noticed people do sometimes is they like take one individual and put one here and one here. No, one individual. All right. Little r, little r. Let's do it. Bring that one down. Oh, Mr. Suter, what are you doing? Mr. Suter, bring that one down. Bring this one over. Bring this one down. Bring this one over. Bring this one down. Bring that one over. That one down. And we're following the Mrs. Smith's rule of always putting the capital letter first. Save and close. What do we have? All right, genotypes. They're all the same. They're all big R, little r. And because you can, control copy. Big R, little r, big R, little. Oh, it's beautiful. Look at that. And if they're all big R, little r, that means they have a big R. And if I go up here, big R is dominant. That means it's going to be round. If we have a big R, we're going to be round. And so I'm just going to type in round really quick. And so I know I could be asking you this stuff in the chat, and we like the chat communication, but just wanted to kind of get you moving so we can go through a couple samples with you. All right. Mrs. Smith, you want to try number 4, or what do you want to do?
Yeah. Do you want to switch the screen? I just kind of shared mine. That way I can write on my own and everything. Or do you think?
Oh, yeah. I get it. You don't want to have to count on me. That's fine. Just make your screen, try this one time, make your screen less wide. Can you look at my screen.
Just go back to yours. That's fine. All right.
Well, all you gotta do is make your window like kind of half minimize your window and then squish it. There you go. Whatever you did is perfect.
Okay. All right.
It's better. Good figure.
So tall plants are dominant to short plants. So that's our first thing that we're going to be looking at here as far as highlighting on that information that we know that tall plants are dominant to short plants. Okay, that's going to be important. So when we're talking about the trait then, our trait is going to be dealing with the height of plants. I know that nowhere in here does it say height. Okay, but we don't just put whatever the dominant trait is. I saw that some of that is happening, that some people are putting in, like when it says what's the trait, they're going tall plants. No, tall is the dominant allele. Short is the recessive allele. Well, short and tall are talking about the height of the plant. Okay, so for this, I guess I'm going to use T, since we're talking about tall, and lowercase t for the recessive of being short. And so what we are going to do is we're going to cross a heterozygous plant with a heterozygous plant. So they are both going to be heterozygous, which means they are both going to be big T, little t. Okay, so if I go down here, double click on my Punnett square, and I look at that, I've got big T, little t, I've got big T, little t, and we're going to bring this one down, this one across. We're going to bring this one down and this one across. Again, making sure that I am keeping those letters, capital letter first, lowercase letter second. Bringing this one down, bringing this across, bringing this one down, bringing this across. So when I'm done now and I'm looking at this one, as far as our genotypes and phenotypes, we've got big T, we've got big T, little t, we've got big T, little t, and we've got little t, little t. So now our phenotype for 2 large alleles or dominant alleles is homozygous dominant, which means we're going to have a tall plant. For the heterozygous, we're going to have a tall plant. So that will also be for this one. And then 2 little t's means that we will have a recessive plant, which will means it will be a short plant. Okay, so that is number 4.
Number 4. Sweet. So those were the 2 that you had to do for homework. And I saw some mistakes. I really think if you keep in mind that homo means same and hetero means different, that really helps. Right? So look at that. So we're going to do, and I haven't looked at these in a year, so hopefully they're not hard. Oh my gosh. We're going to do 2 more. So I don't know how many more we're going to do. Let's see how many more we can do. So let's see how good Mrs. Smith and Mr. Suter are. All right.
All right, you take the next one. I'm going to deal with my son really quickly.
Okay. Don't hurt him. All right. I'm trying to see, can I make it a little bit bigger for you? Oh, look at that. I did, but then we lose the words. If I do this. All right. All right. You with me? Here we go. A round-seeded plant is dominant to a wrinkle-seeded plant. And so that is giving us our trait, right? And so then I lose all my stuff. I'm sorry, guys and gals and all the other beautiful people out there. Where's my thing? Oh, there it is. Whoop, there it is. And I wish Mrs. Hauck was here. I haven't seen her in the chat, but she loves when you do this. This is this annotation of stuff, right? So we're annotating a little bit here. All right. So a round-seeded plant dominant to a wrinkle-seeded plant. What parental genotypes will produce offspring that are 50% homozygous dominant? Oh, man. I got the hard one. 50% homozygous dominant. So that's one of them. And 50% heterozygous. This is really messed up my groove here, having that in a different spot. That's going to drive Mrs. Smith's OCDs nuts, so we're going to leave it like that. So what is the trait? Seed shape. Just like she said, it's not what, it's not what the trait is. What is dominant? All right, dominant. Round seed is dominant. So round is dominant, which means wrinkled. Wrinkled is recessive. Using the R's. I still like the R's. They roll off the tongue. It's good. It's all good. What is the cross? Now, I said this is hard. In the chat, what do you think I should do here? We want 50% of the offspring. We want to figure out what parental genotypes will produce offspring that are 50% homozygous dominant and 50% heterozygous. What would you do? What would you do in this circumstance? You want to take a stab? You don't have to tell me the answer. Just what would you try and do? Because this is different, right? Can you put the cross in right away? What would be the first thing you'd start looking at? What do we know? Do we know the parental cross? Eli, I'm not sure if you're right or wrong. But you're giving me the parents. Do we really know that yet? How did you get that? What's the first thing you would do here? It's quiet out there, Mrs. Smith.
It is not quiet here. Hence why I am muted. Well, it's actually kind of quiet, but.
All right. Somebody, Aiden reminded me that I needed to give you this. So while I'm waiting for an answer, I can do that. We need to get the parent alleles. Yeah, we need to get them. So how would you do it? What would you start with? What do we know?
Okay, so if 50% are homozygous dominant, how many out of those 4 boxes need to be homozygous dominant? Just trying to get you to think about something.
Well, and it's kind of interesting here, right? If 50% are homozygous dominant, we could almost skip, right? We could almost skip the Punnett square and come down here and say we know that 50% are homozygous dominant. I'm sorry.
That's okay. That's heterozygous. That's the other one. Good job.
Right. I got ahead of myself. And we know the other 50%, here we go, are heterozygous. And we can actually put the phenotypes in because if we have a big R everywhere, we know they're all going to be round. So we're kind of working ahead of ourselves a little bit. But if that's the case, we could come up and put them up here too, right? So I could say, I know 2 of these are going to be big R, little r. And I know 2 of these are going to be big R, big R.
Good, Radhika.
Yeah. And so now all I got to do is go, well, if I have a big R here and a big R here, this must be a big R. If I have a big R here and a big R here, this must be a big R. If I have a big R here and a big R here, this must be a big R. And if I have a little r here and a little r here, that must be a little r. And you need to pay attention. This can't be a little r because that's 2 big R's. Right. Really, you would start probably with this box, right? And go, well, that has to be a big R and that has to be a big R. It's probably an easier way to do it. So we save that, and our problem is not done because we haven't written the cross. We can write the cross now, and Eli was right. Right? There it is. All right. You want to do the next one, Mrs. Smith?
Sure. I will attempt.
Shut up. These are tricky.
All right. So in pea plants, purple flowers are dominant to white flowers. So purple dominant, white must be then recessive. So purple dominant, white recessive. So again, we're looking for the parental genotypes, which means we're going to fill this in last. Would produce offspring that are all heterozygous for the purple trait. So trait, flower color. And I think Don was asking, do you have these? No, we're just trying to do some of the more difficult, or I mean, it's not super difficult, but the more complex ones just with you as guiding through things. Okay, so the dominant allele, let's use F, because I don't like P, because they look almost the same. So purple with a big F, white with a little f. Okay, so we know that all the offspring are all heterozygous. So again, like Mr. Suter said, I can go down to the bottom and I can fill out what it's going to be. And I know that they are all going to be purple because of their heterozygous, and they're all showing that dominant trait. Okay, so then I go back up into my box, start here, and I know that they're all heterozygous. So how do I get all heterozygous? Okay, if I get a big F here, I move the big F over here. If I've got a little f, I move it over here. Now here's where sometimes it gets a little bit trickier. Mr. Suter's, he's like, you know, you had 2 T's and you have to pay attention. But when you get down to this box, you've already used the little f up here. So make sure that when you go back over, you use the big F here. So you got the little f up here that's been used in both of these. Okay, and the big F here that's been used in this one. And then in this one, the big F has already been used. So what's left is the little f that has to go up here, which makes sense for this last one, because again, the big F came from here, little f over here. I always suggest double checking and making sure that you followed through everything, because if you try to do it too quick, sometimes what happens is people will go, oh, you got big F, little f, and I've got what I need, but it's not actually going to work the correct way. So the only way to get all heterozygous then is to have one parent that is homozygous dominant and one parent that is homozygous recessive. And for my higher level students, that is what we call a purebred or true cross? Bada bing, bada bing.
I think I'm going to skip down to question number 9. Well, just let me look a second. Let's skip down to question number 10.
Okay.
I'm going to skip down to question number 10. Yeah, and Dominic was right. We don't, you don't, like you said, that we don't have these because we told you this yesterday. All of these questions were questions you would have done if we were in class. And so we are trying to make things easier, kind of lighten the load. We're trying to get you the big picture and maybe not as much reinforcement of that big picture as we normally would. So we really appreciate those of you that are watching and sticking with us and turning stuff in. Yeah, I had more to say, but I'll stop. Let's do this one. This is interesting. Here we go. In goats, a recessive gene causes the goats to faint when they are startled. So a recessive gene causes the goats to faint. I'm going to highlight that. We'll highlight it. When they are startled, a farmer breeds 2 goats that have never fainted. Okay, 2 goats that have never fainted. I think that that's important, right? I think that's kind of like an important piece of information, and I'm going to highlight it as I read. And their first offspring faints 2 days after its birth. First offspring. That seems important too. I don't know. Everything in the question seems important. What must the parent genotypes have been? Oh, poop. We don't know the parents. All right, so what do we know? What is the trait? Fainting goats, right? I guess. Whether they faint or not, fainting goats. What's the trait? Whether they faint or not would probably be better, but I'm not typing it all. What is the dominant allele? Not fainting would be the dominant, right? What is the recessive allele? Fainting. So what letter can we use? Well, we can use F. I would never use an F. We'll use G. No, we'll use an F. I would never use an F if I was writing, handwriting. Typing, it's okay because they look different when you type. Okay? Stay with me on that one. What do we know? What's the cross? We do know something about the cross here. We have 2 goats that have never fainted. So that means they can't have, they're not homozygous recessive, right? They've never fainted. They must have a capital F. And so it's really like what we know right now is this, is big F, and we don't know the other gene. That's what we know. And if we put that down here, if we come down here, we know it looks like this. I'm just going to do it. We know it looks like this. So what do we know about the offspring? Well, we know that this potential offspring is big F, big F. We know this one is big F, and we don't know what it is. We know this one is big F, and we don't know what it is. And this one, we don't know. And then if we go back to the question, sorry, I got to save and close, go back to the question. The first offspring faints in 2 days. So one of them faints. And if one of them faints and fainting is recessive, one of them has to be little f, little f. So now what do we know? We know that this poor goat here has to be a fainter. And then that tells us that that is a little f. And that tells us that that is a little f. And that tells us that that. Mrs. Smith wasn't sitting there when I said I'm only using F's because we're typing. Because if we weren't typing, I would never use F because they look too much like that. All right. Save. Boom. So we got it now, right? So what do we know? Potentially. We know we could have a big F, big F. We know we could have a big... Oh, that didn't go well. What's a fail? We know we could have a big F, little f, big F, little f. And we know we have little f, little f. Ah! What the heck? Fingers are faster than my brain. All right, so what do we have? Faint. We have a fainter. We have a non-fainter.
There you go.
I got my conscience sitting over my shoulder telling me every time I mess up. We have a non-fainter, a non-fainter, and we have a fainter. 25 minutes in. What do you guys think? Should we finish? Should we do the one more? Or let's ask this one in the chat too. And then Mrs. Smith, if you want to do one more, you can pick one, maybe that next one. But I think for number 11, let's just ask this in the chat. You are smart people. You do not need to do the cross. What parent genotypes are needed to result in 100% fainting goats? Same as the last question. Fainting is recessive, not fainting is dominant. To get 100% fainting goats, what did the cross have to be? Let's ask that one in the chat. Drum roll.
Woo! Aiden and Annie.
Oh, they get it already?
Oh yeah, Radhika.
Because I was going for a drum. I was like, drum roll.
They were super fast. They know what it is. In order to get all homozygous recessive, you have to have homozygous recessive parents.
Jake. Radhika. Oh yeah. I got my drum for nothing.
Sorry.
All right. So, what do you want to do, Mrs. Smith? 26 minutes. You want to do one more, or you think we're good?
Why don't we do the number 12?
Okay.
You think? Just because it says 1/4?
Yeah.
Okay. All right.
So
we're looking at number 12. It says, what parent genotypes will result in 1/4 of offspring being fainting goats? Again, remember that fainting is recessive and non-fainting is dominant. And I don't know what your F's look the same. Is that what you're trying to say? Because that's crazy to me. So it says
when kids write F's quickly, they sometimes look the same.
So 1/4 of offspring being fainting. So if fainting is recessive, and you just told me in order to get, that 100%, you need both parents to be recessive. Well, it doesn't say that 100%. It says 1/4. So 1/4 in a percentage wise is the same as 25%. So if I go down to my little square, you've got to have the little f down here, which means the little f goes up here, which means the little f goes over here, whoosh, which means I've got a question mark with a little f and a question mark with a little f and a question mark and a question mark, if you follow Mr. Suter's language there. Now, here's the thing about this is that, if 1/4 are going to be fainting goats, what are the others going to be? And I see some people are already popping things down in the chat. Okay. And they're absolutely correct. Okay. That you follow back through and you want to change those to F's. Now, if we want to talk math, if perhaps the question said at least 1/4 are going to be fainting, could we change what it says? Just curious. There's something to think about. The language, it's like a word problem in math where the language is important to kind of finish. But I think we did enough. We're pushing 28 minutes here. You okay, yeah. Mr. Tudor?
Mm-hmm.
Oh, okay.
Yeah, I was sorry.
Right. So Eli said yes. You know what I mean? If it said at least, you could have something like little f, little f. Okay. You could also have a heterozygous parent that is crossed with a homozygous recessive parent. So big F, little f, crossed with little f, little f. So just something to think about. But it doesn't say at least. It says 1/4. All right. Well, any big questions? Okay. Well, I have to go deal with my lovely children that have been so well behaved these past 29 minutes and 15 seconds.
Uh-oh, they're in for it. You know that feeling? You can hear the mother in her voice. They're dead. All right. Well, tomorrow before we start the live stream, I will make sure to get visual confirmation that our children are okay. And
They'll be fine. I'm not.
I know she doesn't have a mean streak in her. For the rest of you, thank you so much for hanging out with us, watching the rerun or whatever. We like we say every day, we miss you. Wash your hands, take care of yourselves. We love you. You might have noticed that Mrs. Smith and I sometimes talk to ourselves while we're doing these things. And it's just because we need expert advice. Bye.